All right, so in section 2.2, we talked about something called the derivative. And we noticed that this notation looked very similar to what we did in 2.1, where it had two different names. And those two different names were the slope of the tangent line and then velocity. Sometimes you'll hear the phrase instantaneous velocity, more specifically than just velocity. So we encountered that. We had this alternate definition, and we noticed that the only difference between the two was that this one actually leaves x in there as a general statement, whereas this one plugs in a specific value, a, for the x as you're working your way through. And I think I mentioned that by default, this is the one I usually use. And then I just plug the numbers in at the end, because that works for all the problems, regardless of whether a number is given or not. All right, so we did a couple of examples where we worked through all of the algebra. So if algebra is something that you're fairly good at, this is a section that works really well with you. And if algebra is something that you struggle with, it's probably a section that you're going to struggle a little bit more with, because there is intense algebra in this. It has been said many a time before that you're never so good at algebra until you've taken calculus. And it's a very true statement. You get really good at your algebra and calculus. And then we talked about there being these other notations, a little bit of description of what those notations are. All right, the last thing that we were working on, this is the part where we left off, was taking a graph and finding its slope graph, or its derivative graph. And we talked about how we're going to do that. There's 3 steps. The first thing we do is we find out where the slope is 0. The second thing is that we find out where the slope is positive, and then also where it's negative. And then sometimes, if we don't have enough information given to us by those first 2 steps, we will talk about how the slope is changing itself. Okay? And we'd gone through a few examples. We looked at something like this. We had a graph that was, had some curvature to it, and it ended up looking like a sort of like a parabola. We had a graph that looked a little bit like a parabola, and it ended up having one version of it looking like this. Our other version was that it was a line, or it could be a line. We had a diagonal line, and we found out that its derivative was actually a horizontal line, and we were ready for number 6. Okay? So what we're going to do is the same thing as last time. We're looking at how in the world we can describe the slope of this graph. So the first thing we're going to talk about is where the slope is 0. So what can we say about the slope of this one and the number 0? Any thoughts? Yeah, it's actually not 0 ever, right? So you can certainly write down the slope is never 0. What is something else you could write about the number 0? I don't think I asked that very well. Let me try that again. While there isn't a slope that's actually 0, there are slopes in this graph that are almost there. So that might be a helpful thing to write down. Something like the slope is almost 0. Yeah, as you approach negative infinity. Or you can even be a little bit less precise and talk about it being on the left-hand side of the graph or something like that. So the slope is in fact never 0. But you could also say the slope is nearly or almost 0. And I'm just going to use the phrase on the left. Christian, you said as you go to negative infinity, which is even better, so that'd be great. So if you want to say as x goes to negative infinity, that's fantastic. All right, now then, slope being positive, negative, what can you say? Yeah, the slope is always positive, right? Now, I'm going to flip the slide back to the previous slide and make a mention of something we did last time. With the exception of my statement here about being nearly 0 on the left, the first 2 statements are exactly the same first 2 statements as the last problem. The last problem we said the slope is never 0. We said the slope is positive everywhere. And that's the same statements we've made right here. But the third statement is different. On the third statement on this one, we said the slope is constant. What can you tell me about the slope of this graph? Yeah, and you're right, it actually is exponentially. If you think about drawing tangent lines, if you're having trouble seeing this, imagine what we're actually calculating. We're calculating the slope of tangent lines. So here's a tangent line, and here's a tangent line, and here's a tangent line. And if you think about the slopes of those lines, what are the slopes of those lines doing? They're increasing, right? So we are actually now going to use the phrase increasing, which I told you last time we didn't want to use it because we didn't want to confuse positive and increasing, which is a really easy thing to do. We're going to write the phrase down that the slope is increasing. And it's not because it's positive. Okay? That has nothing to do with it being increasing. It's because as I draw those tangent lines and I move from left to right, it gets steeper. Those lines are getting steeper. So the slope is increasing as we go to positive infinity. Or even better, we can say as x goes to positive infinity. Or you can say as you move towards the right. That would be fine as well. The language that you're using down here in these notations is meant to help you to be able to draw the graph. So the fact that you're not being super precise in the language is not a problem. It's supposed to be helping you draw the graph that you're about to draw later. All right, what is the next thing that I did last time? Do you remember?
Crossed out slope and put y value.
Exactly. Everywhere we wrote slope, we're going to cross it out and we're going to write in y value. And as we do that, it's helpful if you have another color. The bulb is really dim up here, which is why you're not being able to see my colors very well, and it ends up looking like a mess. But hopefully on your paper, when you switch colors, you can distinguish it a little bit better. And we're going to draw an xy axis. The xy axis needs to be fairly close to the xy axis I was given. Occasionally it'll be, something where you need to go beneath the x-axis or something like that. On this one, we aren't going to need to do that. How do I know I don't need to go beneath the x-axis on this graph? Yeah, slope's never negative, right? So I really am going to be completely above the x-axis basically because of statement number 2 on there, right? The one that's number 2, that we're always positive. Okay, the fact that the slope is never 0. So let's think through this. What does the fact that the slope is never 0 mean? I'm never going to touch the x-axis. Okay, that's a good point. So keep that in mind. You're not going to hit the x-axis on this graph. The second one says the slope is nearly 0 on the left. Okay, so now I'm going to make something about the y value. What does it mean for the y value to be nearly 0 on the left?
It's almost horizontal line.
Yeah, there's approaching a horizontal line. It's an asymptote. So over here on the left, it's going to be very, very, very near to that axis, very much like an asymptote would be. That's exactly right. Number 2 actually said the y value is always positive, so we already kind of established the fact that means we're going to be above the x-axis the whole way. But what? I mean, what does it look like as we're going to be above the x-axis? Well, what does number 3 say?
It's increasing as x goes to infinity.
The y value is increasing as we move right, as x goes to infinity. What's this graph going to look like? It's going to look the same. Now, it might not be exactly the same. It depends on the function that we're given. But it's going to have the same overall shape. Everything that we just described about the slope of the original graph is actually true about the y value as well, which is a little strange. This is the only graph that does this. There are no other graphs that actually have this feature to them. Okay? Any questions on this one? Yeah, Matt.
In the homework, do you want us to also cross out slope and put y value?
Yeah. Yeah, when you're doing your homework, I expect to see steps 1, 2, and sometimes 3 as you're writing down those details. Absolutely want to see those. And so everything we've done in class where you're marking them out and as you're going along the way, yes, exactly. All right, 7's interesting, isn't it? It's a piecewise function, so it has lots of pieces that we have to sort of describe as we're doing all these details. But we're going to do all the details in just the same order as we did before, talking about the slope. So let's talk about where the slope is 0. Where do you see 0 slopes on this graph?
On the third zero.
Okay, this one right here, Christian. So from at 3? Just at the number 3?
No, after.
Okay, so like from 3 to 4?
After 4 to 5.
And from 4 to 5. Okay, so the slope is going to be 0 on the interval 3 to 4. And we probably should put in parentheses here the 3 to the 4. At the very least, the 3 doesn't count because there's a open hole there here, and then the 4. And again, because there's a jump here at 4, we can't include the 4 either. And then also then from 4 to 5. So there's going to be a slope of 0 from 3 to 4 and from 4 to 5. Those are the only ones that we can tell for sure are zeros. But there's probably some others that we can make a comment, kind of like we did as our secondary comment on this one about number 1, where we talk about things being nearly 0. So where is the slope nearly 0?
X goes to negative infinity.
Right, as x goes to negative infinity, or you can say on the left-hand side of the graph. There's also one other place. Where else does
Goes
it?
plus and
Well, the
y-axis.
no, because that would be a very steep slope there at the y-axis. So I don't think that one's the one we want. Was there another one? It's okay, just turn it off. There's one other place where it has this sort of flattening out feature going on. Where is it? Yeah, 3 from the other direction that we haven't already identified, right? So also, as x approaches 3 from the left, that's one way we can write it. Or you can put that in words. You just, as the graph is getting close to 3 on the left, from the left-hand side of it, and that's fine. Your notation is not important here at this point at all. Okay, so 3 from the left. Okay, I think that's all for our slope being 0. Now we're going to move from left to right, and I'd like for you to tell me what you see in terms of the slope being positive or negative. So what is happening first? Okay, so I'm going to actually write this because we have several intervals. So I'm going to write this as negative infinity to 0. So what happens from negative infinity to 0? What's the slope doing?
It's negative.
It's negative. So the slope is negative. What about from, looks like 0 to 3? Also negative. And then we've already established the 3 to 4 and the 4 to 5, what's happening, right? Okay, so we have 2 places where the slope is negative. And then I'm going to do step number 3 over here because my spacing's a little bit off the way I chose to write that. Maybe I'll do it this way. Okay. Slope is negative 3. There we go. How's the slope changing? In particular, we don't need to worry about the flat pieces. We already described them as fully as we can. But what's happening on the other 2 pieces? In particular, we'll go again from left to right. What's happening from negative infinity to 0? There is an asymptote at x equals 0.
Slope is getting bigger.
This-
Smaller and smaller.
The slope, we'll say, becomes more negative. Right, and again, let me draw a couple lines in there to verify what we're seeing, like I did in the last one. In particular, if you talk about this slope of the tangent line and you compare it to this slope of the tangent line, provided I could actually get it to cooperate, there we go. It's getting more and more steep, definitely steep, but in a downhill way. So these are big negative numbers, big negative slopes. And so the first one might be, negative 1/2, and the second one is negative 6, or something like that I just drew. I don't know, because I didn't put a scale, but something like that. Okay? What about the other one?
Less negative.
Yeah, so when we go from 0 to 3, 0 to 3, the slope becomes, we'll say, less negative. That will work. You could also say the slope approaches 0, or it starts out very negative and approaches 0. Any of those languages that describe that would be sufficient. All right, so now as I'm drawing my graph, I need to make sure that my axis has the same x, y values on it, in particular the x's that the previous one did. So I need to go out 5 to the left, or to the right, and at least 1 to the left. And then the scale on the y is not quite so important, but we can put it in there anyway if we'd like. Something like this. All right, so let's start with the beginning. What does it mean for us to have a slope of 0? Oh, I'm sorry, I missed something. What did I miss? Yeah, I missed crossing a mountain. I'm getting ahead of myself. Everywhere I wrote slope, we need to write y value. Okay, so y value is on top of all of those, so to speak. So let's do the first one then. I need a y value to be 0 on the intervals 3 to 4 and 4 to 5. What will that look like? Okay, so horizontal, there's your right word, right? Horizontal line, where?
On x-axis.
On the x-axis, right? Because the x-axis is the value 0. So mine is not going to show up very well, so I'm just going to use a wider brimmed marker just to make it show up. So from 3 to 4 and from 4 to 5, I've got this image right here. You can kind of see it looks like it has depth to it. But the end points of it are not included, so there should be open holes at each of those other values. Okay, so the graph looks very messy now, and especially with the low bulb strength, so you can't see it very well. But I've got an open hole at 3, an open hole at 4, and an open hole at 5, and then I'm actually on the x-axis between them. Okay, so that's part of the graph. This one tells us, step number 2 tells us the slope is negative on the other two pieces. So what is the fact that the slope's negative telling me? I'm going to be below the x-axis the rest of the time, right? Okay. I did skip over one where it says that the slope is nearly 0 as x approaches negative infinity. Kind of skipped over it on purpose. It's nearly 0, but it's nearly 0 where? Above or below the x-axis? Below. So I'm going to be over here somewhere on my graph, below the x-axis, but approaching the x-axis. Okay, so the next thing to do is to talk about what's happening between negative infinity and 0. We're basically on step 3. So what's going to happen? This piece of it's going to look the same, because it's supposed to be giving me y values that get more negative as I move from left to right. What's going to happen between 0 and 3? I mean, I'm under the x-axis. We already said that.
It's gonna be like,
Yeah, I see a lot of you making motion that it's going to look something like this. Now, this value at 3, you could actually hit the x-axis in that open circle if you like, or you can be just slightly lower than it if you like, because again, we don't have a scale to know for sure. It's quite possible, because of the way it's drawn, that this really is basically like a parabola down here, and this actually is 0, but it wouldn't have to be, because we can't see that closely to know. So it also could be slightly positive still, slightly negative slope still, in which case we would be slightly underneath the x-axis at that point. Okay, does that make sense? Okay. The last question on this is actually one of these kind of questions where your graph and my graph may not match perfectly. There will be some features that will be the same, but we have some flexibility with some other stuff. So let's take a look. We're going to sketch the graph of a function with the following properties. So the first 3 properties are going to be the same on all of our graphs. There's one and only one way to draw each of those. Okay? So we're going to start with that. Go ahead and sketch yourself an axis. I'm going to try to make my graph's axis a little bit thinner so that maybe when I use a different color it'll show up a little bit better. Okay, so here's an axis. And given my axis, I'm supposed to be, basically these first 3 that I've underlined in red are points that I'm going to be plotted, right? So this one right here is the point -2, 2. And this is the point 0, 3, and this is the point 4, 1. Everybody recognize that okay? So we're going to plot those 3 points. So I actually need to mark out some x and y values on my graph. So 1, 2, 3, I at least need to go out to 4. Apparently at least need to go up to 3, so I'll just put 4 in each direction, which is more than sufficient. All right, so one of my points to plot is -2, 2, which should be something like that. Another point I'm supposed to plot is 0, 3, so I'm about right here. And then 4, 1, which is about right here. Those pieces have to match on all of our graphs. No flexibility. All right, now it tells us a piece of information that's a little different. It doesn't tell us about points on the graph itself. It tells us about the derivative. What does the derivative tell us? The slope. So this notation right here is telling us that the slope at x equals -1, that's why this -1 here, is 0. What does it look like to have a slope of 0? What are our options on how that could actually happen? Okay, so you could have like a maximum point, right, where it's sort of opening downward, or you could have a minimum point where it's opening upward, or it might just be a flattening out spot. I mean, those are basically the three choices. So we have to do one of those things at x equals -1. Now, looking at the graph between basically -2 and 0, here's my -1, we kind of have to make a decision. Is it going to dip downward? Is it going to go upward and come back down? So we get to pick. We can either do something maybe like this, or like this, and it's our choice. Now, we may make a choice and find out after we do the next step that it wasn't a good choice and go back and change it. I mean, it's hard to tell, but we get to make a choice. So what do you want me to draw for the first one? Can I leave it like that? You good with that? Okay. So we'll leave it as we did on this one right now. All right, another piece of information then, I think this is the last one, isn't it? The last piece of information tells us that at x equals to 2, what does it tell us? This is not telling us a value of 0 now, so what is this saying? The slope is negative at x equal to 2. Well, what does a negative slope look like? It's going downhill, right? So over here is 2. At the x value of 2, it's supposed to be going downhill. Agreed? So as I cross wherever I'm going to cross at the number 2, it needs to be a graph that's decreasing at the value 2. So the graph has to be doing something like this at 2, but it needs to be connected to what else I have. So perhaps we will change the, oh wait, that's not what I want to do. How extreme my dip up was, or my lift up was, just to make it easier to draw down here. Maybe something like that. Am I going downhill at 2? Do I have a maximum or a minimum at -1? And I hit through all the other points, right? So then we would just finish it out the graph by showing the end behavior of it, however we chose to show the end behavior. You also don't have to draw it this way, right? So like in between here, maybe you don't draw it this way, maybe you do this. That's supposed to connect, okay? Maybe it sort of looks like a really wide parabola. This is not a very good rendition of that, but maybe it has that sort of a feature to it where it continues to go downward. That'd be okay. Any other questions on this one? Let me draw one other version of this just so you can see that if I had done the graph differently to begin with, it could have changed the very picture that we were dealing with. Earlier, one of the things we said we could do is we could do this, right? Agreed? So if we did this kind of a graph, we would sort of naturally be inclined to keep increasing after x equals 0, but we have to be decreasing by the time we get to x equal to 2. And we could do something like that. Right here, it's about x equal to 2. Is it decreasing? Yep. And it would probably be natural to finish it out on that side that way. Those are very different pictures we just drew, but they fit all the details we were given. Okay? Any questions on that one? All right.